Good morning. Morning.
Hey, when was the collision due by?
Uh, Yesterday at midnight?
Okay, that's pretty good.
Okay. Okay. So, We had a quiz over the weekend, and I'd like to go over that now. From what I've seen, looks like we did pretty well on it, which I'm happy to see. Typically, this kind of stuff is something that my students in the past have sort of had difficulty with, but it doesn't seem like too many of us are having too much of a hard time with it. So, let me just pull up the quiz real quick. Okay. So number 1 says, consider the following linear inequality. And it gives us, give me a second here, there we go. It gives us 5w minus 6 is greater than or equal to 5 plus 7w. Okay, so what it wants us to do is it wants us to solve this and put our answer in terms of an interval. And then it also wants us to graph it. Okay, so let's, of course, start by solving it. So I want to get, let's see, it's negative 7w with the other w. So that cancels. This gives me negative 2w. Minus 6 is greater than or equal to 5. I want to get the constants together on one side, so I'll take the 6 to the other side by adding. That gives me negative 2w is greater than or equal to, let's see, 11. And then one last step, and that is to divide by negative 2 on both sides. But remember, something happens there when we divide by negative like that. And that is that the inequality sign flips. Because dividing by a negative number changes our weight. It flips our weight around. So now we have w is less than or equal to negative 11 over 2. Now, for the purposes of graphing this, honestly, it's going to be easier if we convert 11 over 2 into a decimal. So, negative 11 over 2, that's going to give me negative 5.5. Okay. So let's graph it, and let's get our answer as an interval. Because honestly, I feel like graphing it is the easiest way to see that interval. Okay, so I know that w is less than or equal to negative 5.5. So I'll say that like 5 is here, meaning that 5.5 is like right here. Oh, whoops, it'd be farther than that, wouldn't it? 5.5 would be right there. So we can be equal to it. So we use a closed dot to show that. And w is everything less than or equal to negative 5.5. So everything less than or equal to that would be all that. So there's our graph. And then as an interval, we can say that it starts at negative infinity and then goes to negative 5.5. So we can't be equal to negative infinity, but we can be equal to that 5.5. So we'll use a bracket around it. Any questions? Nope. All right. Next. Says, solve the following quadratic equation by factoring. If needed, write your answer as a fraction reduced to lowest terms. Okay? And what it gives us is 36 z squared minus 4 is equal to 0. So the easiest way to tackle this one would be to factor this quadratic and then use our zero product principle to solve. And if we look at this one, it's a difference. So you should probably look and see if those are squares, and yeah, those are actually square numbers. 36 is the square of 6, z squared is the square of z, 4 is the square of 2. So we know that this is a difference of squares, and that's going to factor as two factors. One being positive, one being negative, and then we just fill in the blanks with the square roots of these numbers. So like square root of 36, z squared is going to be 6z. Square root of 4 is 2. Remember, the factored form is still the same thing. It's still equal to 0. So now we can use our zero product principle to say that, well, if we're multiplying two numbers and getting 0, one or both of those numbers would be 0 as well. So 6z plus 2 could be 0, and 6z minus 2 could also be 0. So now it's just a matter of solving each of these. Well, let's see, minus 2 to both sides, that gives me 6z equals negative 2. Then divide by 6, and that gives us z is equal to negative 1/3. The other one's going to be basically the same steps, add to except, in this case though, and we would get z could also be equal to positive 1/3. So same exact steps in solving that, we get positive 1/3. And so there's our two answers. Any questions? All right. Next. This one we want to solve, and we've got kind of a quadratic blown up across a equation. So we've got 10x squared plus 32x equals 9x squared plus 36x minus 3. So the first thing we want to do is consolidate everything, get everything on one side and equal to 0. So I'm going to subtract 9x squared minus 36x and plus 3. Bring all that to this side. So minus 9x squared minus 36x plus 3. So everything on this side will cancel, leaving us with 0 on that side. And then on this side here, we'll get x squared, let's see, minus 4x plus 3 equals 0. Still with me so far? Okay. So now we have a nice, neat little quadratic equal to 0. This is something that would be pretty easy to solve if we factor it. So, do our AC method. A is 1, C is 3, AC is 3. And lucky for us, there aren't too many factors of 3, just 1 and 3. So we want to get somehow this equal to negative 4. Well, negative 1 and negative 3 will give us negative 4. And of course, because our leading coefficient here is positive 1, that means we can use our shortcut and say that our factors are x minus 1 and x minus 3. And that still equals 0. Well, really just one step left here. We've got to use our zero product principle. So x minus 1 could be equal to 0, and x minus 3 could be equal to 0. Which, if we solve both of those, means that x could be equal to 1 or 3. Any questions? Okay, next we've got y minus 9 squared equals 25. And this one says solve the following quadratic equation by factoring. Not a whole lot of factoring in this one. It's really already factored to a point that we can solve it. Now, of course, we could do, okay, y minus 9 squared, multiply that out, and then take 25 to that side, and it would give us a quadratic equal to 0. But again, this I feel like is actually already in a form that is factored and can be solved. So we've got a square on this side. We want to get rid of that square. We take a square root of both sides. So on this side, that gives us y minus 9. That square is gone now. Remember, on this side, when we take that square root, this is going to give us 5, but not just 5, plus or minus 5. And then one step left, and that is to move 9 to the other side, so we have y equals 9 plus or minus 5. Okay, well, we can find both of those answers. 9 plus 5. That's going to be 14. So y could be equal to 14. And then 9 minus 5 would be 4. So y could be 14 or 4. Any questions? None? Okay. Next one says solve the following quadratic equation by using the quadratic formula. So I'm going to get a new piece of paper just for that. So the equation it gives us is y squared plus 18y plus 77 equals 0. And our formula, our quadratic formula, says x equals negative b plus or minus the square root, of b squared minus 4 times a times c all over 2 times a. Now for this one, just replace x with y, and we've got something that'll work. So what we're going to need to do is define our a, b, and c. Well, looking at the typical form of a quadratic, our a is that leading coefficient right there, in this case positive 1. B is the number in front of y, positive 18, and c is this constant, positive 77. So once again, that's a, b, and c. So now all we have to do is plug these numbers in see what we get. So, again, I'm going to change that to y real quick to make it fit this formula, fit this equation. So negative b, that's going to be negative 18 plus or minus the square root of 18 squared minus 4 times a, which is 1. So I'm just going to say 4 times 1. And then 77. Then all over 2 times a, so 2 times 1. Okay. So, we need to start simplifying this. In here, we've got 18 squared. 18 squared is 324. So now we have y equals negative 18 plus or minus the square root of 324 minus, let's see, 4 times a times c. 4 times 1 times 77. That's really like 4 times 77. So that's 308. And that's all over 2 times 1. Of course, that's 2. Simplify it a little bit further. 324 minus 308 is 16. So now we have y equals negative 18 plus or minus the square root of 16 all over 2. Of course, the square root of 16 is 4. So y equals negative 18 plus or minus 4 all over 2. All of these can be divided by 2. I can basically cancel out a 2 through all of these. So that gives me y is equal to, let's see, negative 9 plus or minus 2. Okay, well, negative 9 plus or minus 2, that's going to give me y equals, let's see, negative 9 minus 2 is going to give me negative 11, and then negative 9 plus 2 is going to give me negative 7. So here's my 2 answers. Using that equation, that formula, is pretty involved, yeah. But again, like I said last week, no matter what kind of a quadratic you have, this will solve it every single time, no matter what. Any questions? All right. Let's go on to the next one. Okay. So here it gives us a rational expression. It gives us 5y squared minus 14y minus 24 over y squared minus 6y plus 8. And it wants us to do 2 things. First, it wants us to simplify, and then it also wants any kind of excluded values. In other words, the domain. Of course, we're working with y here, so it would more be like the range. I'm still going to call it domain. Okay, so the first thing we should really do is find that domain. Find any excluded values. And for a rational expression, that means that the bottom cannot be equal to 0. No matter what we have, if it's a rational expression, that bottom cannot be 0. So we take whatever's on the bottom, in this case, y squared minus 6y plus 8, and say, all right, that cannot be equal to 0. And then we factor it to try and solve. So my a is 1, my c is 8, my ac is 8. really only two that are going to work here, and that's 2 and 4 if we make both of them negative. Okay, so the factored form using our shortcut method is y minus 2 times y minus 4. And of course, again, that cannot be equal to 0. Then, using our zero product principle, we say y minus 2 cannot be equal to 0, y minus 4 cannot be equal to 0, which means that y cannot be equal to 2 or 4. Okay, so there's our domain, or really range because it's y. We'll just call it an excluded value. Now we want to simplify this, so what we're going to want to do is get everything factored and see if we can cancel out any common factors between top and bottom. Lucky for us, bottom's already factored. We can just use that. So let's go ahead and tackle this. So we've got, let's see, 5 times 24 to get our AC. That's going to be negative 120. Okay. And we're looking for negative 14 there in the middle. Right there. Okay. So let's see, factors of 120. We've got 6 and 20. We've got 1 and 120. We've got 2 and 60. 5 and 24, of course. 3 and 40, you said? 8 and 15. Yeah, 10 and 12. Are there any others? I can't think of any. Okay. So again, we want negative 14 there in the middle. So what's going to give us that negative 14? 6 and 20. But I'm coming across a problem here. Our AC is positive 5 times negative 24, right? So that gives us negative 120. Our B term is negative 14, right? So if we use 6 and 20, oh no, that'll work. Yeah, you're right. 6 and 20. So if we make this positive 6 and negative 20, that'll work. Okay. For some reason, I was thinking both of them would have to be negative. I don't know. Okay. So we can go to our box method now. And throw those terms in there. So 5y squared goes there, 24 goes here, and then let's say positive 6, y goes here, and then negative 20y goes there. Okay. Okay, so what can come out of this first row? Yeah, we can take out a y. How about the second row? Get the biggest thing that can come out of both of them. Yeah, I think 4 is the biggest I can take out. This column right here. 5 and y, and then this column. Yeah, 6. Good. All right, y'all still good at that. So our two factors are 5y plus 6 over 5, whoops, not over, 5y plus 6 times y minus 4. And then, of course, we factored the previous one on bottom, and we got y minus 2 times y minus 4. We can cancel out the y minus 4's, and we get 5y plus 6 divided by y minus 2. And there's our simplified form. Any questions? Okay. Next, pretty similar. We've got another rational expression. We've got x squared minus 7x plus 10 over x squared minus 4. So once again, what we want to do here is we want to simplify and state whatever excluded values we have. Okay, so again, bottom part has to be not equal to 0. X squared minus 4 cannot be equal to 0. Now, when I factor x squared minus 4, what kind of thing is that? How am I going to factor it? It's a difference of squares, but yeah. Exactly. So this is going to factor as x plus 2 and x minus 2 is not equal to 0. And of course that means that x cannot be equal to negative 2 or 2. So there's our domain. Can actually call it a domain this time because it's x. Okay, again though, we want to simplify this, so we're going to need to factor that top part. So we've got x squared minus 7x plus 10. Our AC is 10. Factors of 10, stuff like 2 and 5. 7, okay, we make both of those negative, we'll get that 7. And again, using our shortcut method, we can say that the top part is then x minus 2 and x minus 5 over x plus 2 times x minus 2. So what can we cancel out? Yup, x minus 2. Good. Which leaves us with x minus 5 over x plus 2. And there's our simplified form. So once again, we've got our domain and our simplified form. Any questions? None? All right. Last one on the quiz. I've got here z squared minus 8z plus 15 over z plus 10 divided by z squared plus 3z minus 18 over z plus 10. Okay? Now I see that I have a fraction divided by a fraction. Anytime I see something divided by a fraction, there's something I want to immediately do. Does anybody know what that is? First step I need to take here is actually rearranging my problem a little bit. That is, if I'm dividing by a fraction, I need to keep, change, flip. That was a problem I saw with the quizzes a little bit. So, z squared minus 8z plus 15 over z plus 10 is going to stay the same. But we're going to change this to multiply by z plus 10 on top, and then on bottom, z squared plus 3z minus 18. Okay? So now let's go ahead and factor things and then see what we can cancel out. So z squared minus 8z plus 15. I can say there's AC of 15 here. Factors of 15 are like 3 and 5. If I make both of those negative, I get that negative 8 I'm looking for. So using the shortcut method, I can say that the top part is z minus 3 times z minus 5. That's still over z plus 10. Then over here I've got z plus 10 over, let's see, my AC here is negative 18. I need to get a 3 out of that, so 3 and 6. If I make it a positive 6 and a negative 3. So let's see, I got z minus 3 times z plus 6. And now what can I cancel out? Yeah, z minus 3. Is there anything else I can cancel out? Anything else? No. Okay, good. So, on top I'm left with z minus 5, and on bottom I'm left with z plus 6. And there we go. Wasn't looking for a domain on this one, just wanted the simplified form. Any questions? Any questions over the quiz at all? None? Okay, again, from what I saw, looked really good. Now before we go, I want to introduce us to another idea. We don't have a whole lot of time left in class, so I don't want to get into anything too complicated. But remember that when we're dealing with something like a rational expression, something like 17 over x minus 2, that we have to take into consideration that there's something we can't plug in for x. Again, we don't want that bottom part to be 0, because if we divide by 0, well, it kind of breaks. So what we do is we say, okay, this bottom part, x minus 2, cannot be equal to 0. Solve it, we get x cannot be equal to 2. Simple, right? There's another place that this occurs, and that's with radicals. So let's say I have a square root. Okay? And underneath this square root, I've got x minus 2. Now, can I have 0 underneath the square root? Absolutely I can. The square root of 0 is 0. After all, 0 times 0 is 0. So yeah, it's fine for me to have 0 underneath that root. But where do we start getting problems if we have what kind of number underneath a root? We know how to deal with them, but it still makes things kind of weird, doesn't it? Negative numbers, yeah. So we know how to deal with negative numbers underneath the root. If we have like negative 1 under there, oh, that's just I, right? Here's the problem. We're about to be getting into things called functions. And functions, they don't work very well with these I things, not what we're doing with them anyway. So when we have a negative underneath that square root, we're jumping from one number line to another completely different number line. And we don't want to do that. We want to stay on one number line. So what we say about these radical expressions is that whatever's underneath the root cannot be negative. Okay, so in this case we have x minus 2 under there. Any ideas on what we would do to say that it can't be negative? Kind of like how we said that this can't be 0. That would just get us back to the same thing. We want to set this kind of equal to something. Well, if it equals 0, just get that. So remember, we don't want it to not be 0. 0 is fine here. We just want the negative numbers gone. So how do we say that? We say it must be greater than or equal to 0. Because any number that's bigger than 0 is positive. And hey, if we're equal to 0, then we're just 0. That's fine. But anything smaller than 0, well, that's when we start having problems, isn't it? Because anything smaller than 0 is negative. If we take a square root of that negative, then we're skipping over to that other number line. So now we can solve this by taking negative 2 to the other side, and we can say that x is greater than or equal to 2. So as long as we're bigger than or equal to 2, we're fine. We don't need to worry about anything too much. Make sense? Let's try another. How about square root of 3x plus 5? So again, what are we going to do to find our excluded values here? Well, we're going to take this thing underneath the root and do something with it, right? So 3x plus 5, what? Greater than or equal to 0, yeah. It's going to be that every single time. And so we solve, take the 5 to the other side, we get 3x is greater than or equal to negative 5. Divide by 3 on both sides, we get x is greater than or equal to negative 5 over 3. If we plug that in for x, of course the 3's cancel and we're left with negative 5. Negative 5 plus 5 is 0. It's fine to have 0 in there. But if we go below that, if we go lower than that, then it's not going to work. We have to be greater than or equal to negative 5 over 3. Last one, let's try this. Square root of negative 7x plus 5. 8. Okay? Once again, we've got to take this thing underneath the root out. And what's it going to be? Every time. Solve it for me. So I get negative 7x is greater than or equal to negative 8. Go on. Okay, so I've got x is what? Try again.
Well, the sign would flip.
Yes.
You're dividing by a negative.
So we get x is less than or equal to, let's see, negative 8 divided by negative 7, that's 8 over 7. Don't forget that step there. If we divide by a negative number on both sides or multiply by a negative number on both sides, that inequality flips. Excellent. Good job. Okay, so we're going to be dealing with this for the rest of the week. Just keep this in mind. But I think that'll do it for today. So I'll see y'all Wednesday, and hopefully I'll have the grades for the quiz out tomorrow.
You get that?
You too. You too.